Welcome to the fourth and final part of this virtual geology field trip around Flamborough Head. This part of the tour is to the sheltered southern side of the headland that overlooks Bridlington Bay. The shore and its coastal exposures is accessed at three localities: South Landing, Danes Dyke and Sewerby Steps. Unlike the locations visited in the previous parts of this tour, it's possible to examine continuous lengths of the cliffs by working from one access point to the next, and, if necessary because of the state of the tide, to return via a cliff top path. We'll be starting at South Landing, working our way more or less westwards to Danes Dyke, then continuing to Sewerby. But in real time, you're advised to cover each leg separately. There are no escape routes from the shore other than the three mentioned. We shall be moving up the upper Cretaceous stratigraphic column, though all of the chalk sections are in the Flamborough chalk formation, and we shall be discovering more information and detail about the Pleistocene deposits that cap the cliffs along this stretch of the coast. As a recap, compare the shape of the coastlines on each side of Flamborough Head. The north-facing cliffs overlooking Filey Bay are sculpted into narrow inlets and coves, and there are many examples of the features of marine erosion: caves, arches, stacks and stumps. There are also several examples of collapsed blowholes, as we saw in parts 1 and 3, which have made a major contribution to the shape of the coast. In contrast, the south-facing cliffs, which overlook the calmer Bridlington Bay, are smooth and lack many of the classic textbook erosion features of the north. In the first three parts, we worked our way up the Cretaceous stratigraphic column from the lower Cretaceous Hunstanton Formation and the lowest part of the upper Cretaceous chalk group, the Sewerby Formation, at Speeton, then through the Welton and Burnham Formations, exposed at Bempton Cliffs, Thornick and North Landing, to the Burnham-Flamborough Formations boundary at Sellex Bay and High Stacks. We've noted the occurrence of paleo-valleys, which, because of their infillings of gravels and till, we assume to be pre-Devensian in age. The Pleistocene deposits will demand much more of our attention in this part of the tour. We'll start at the Living Sea Centre of the Yorkshire Wildlife Trust, above South Landing, where there are good car parking facilities and usually an interesting collection of locally derived fossils. Access to the shore is along the path down a 250-metre wide paleo valley filled with Quaternary deposits exposed by the downcutting of the present-day stream. The two sides of the valley at the outfall to the shore are known as East Nook and West Nook. The cliffs to the east of East Nook consist of chalk beds belonging to the Hagenovia rostrata zone of the Flambre chalk formation, which extends to High Stacks, the final locality visited in part 3 of our visual tour of Flamborough Head. The South Landing Paleo Valley has cut down through the chalk and its eastern side is clearly visible. The sediments that now occupy East Nook consist of up to 10 metres of coarse chalk gravels that are characteristically lacking in exotic erratics, and they're overlain by till identified as Devensian skipsy till. The gravels, which contain poorly rounded clasts, have been cemented to form calcrete blocks, seen here. The gravels are interpreted as being the product of a westerly prograding glaciogenic fan from an ice front to the east of South Landing. The cliff section at West Nook presents the western side of the Paleo Valley and a more complex set of Quaternary deposits, all believed to be younger than the gravels of East Nook. Two northerly sourced gravel units are separated by a finer interbedded sediment believed to have been deposited in a proglacial lake which formed when ice occupied what is now Bridlington Bay and blocked drainage southwards. Recent work at Sheffield University using a technique called optically stimulated luminescence, OSL, can determine the age of burial of individual quartz grains. Samples have been taken from the lowest gravel unit and produced a date of 35,000 years. If correct, this implies that the last ice sheet arrived in the area north of Flamborough Head earlier than previously documented. It may provide significant new evidence for the timing of glaciation in eastern Britain. Similar samples were processed from the higher gravel unit and gave an OSL date of about 20,000 years, just before Flamborough Head was overtopped by the Devensian ice sheet. In February 2018, extraordinary weather conditions, dubbed the Beast from the East, stripped away much of the rock debris and seaweed covering the wave-cut platform. It revealed, at least for a short period, evidence to support the presence of a north-south trending fault, which was undoubtedly a controlling factor in the location of the Paleo Valley at South Landing. A continuous section of the Flambre Chalk Formation can be followed by walking westwards at the foot of the cliff towards Danes Dyke. The chalk beds are generally dipping gently southwest, so as we work towards Bridlington, we encounter younger strata and thus move up the succession. The section that we'll encounter on the route to Danes Dyke is in the Santonian stage of the Upper Cretaceous, which began about 86 million years ago. And we will pass from the Hagenovia-Rostrata zone through the entire zone of Uintercrinus socialis into the Marsupites testudinarius zone. So we shall be keeping a sharp eye out for specimens of the zone fossils. Logging and leading groups to study the chalk along this section from South Landing to Sewerby presents several difficulties. The coastline is relatively smooth, with few clear reference points, unless you walk out onto the wave-cut platform or beach to look back at the cliff tops. Providing accurate locations of relevant sites is therefore a challenge. The section is also prone to rockfalls and mudflows that regularly obscure several short lengths of the section, and there are many relatively small faults, often making it very difficult to correlate across the fault plane. For example, this fault may be interpreted in two ways. Is it a reverse fault, downthrowing the thin bed A to the left or east? Or could it be a normal fault, downthrowing the massive chalk unit westwards? Finally, the use of lithostratigraphy, which relies heavily on the recognition of distinctive marker bands and their spatial relationships, is more limited in the Flamborough Formation because there are no bands of flint. And not all of the marl seams are reliable for correlation over more than a few tens of meters. They thicken and thin laterally, they divide or even peter out completely. Correlation thus relies on variations in patterns of rhythmicity of chalk beds, a few thick marl seams, and distinctive fossil content. The 1.5 kilometre long section between South Landing and Danes Dyke contains 55 metres of chalk with 125 marl seams. The lowest beds, which are massive chalk units containing the first two significant marl seams, belong to the zone of Hagenovia rostrata. A change to more thinly bedded chalk marks the start of the Uintercrinus socialis zone, which is 39 metres thick and comprises alternating leaves of thinly bedded and massive chalks. The Flambre chalk contains numerous stylolites. These are black zigzag lines of marl produced when pressure caused the chalk to dissolve, leaving behind the insoluble residue. Note how the stylolites pass through the chalk contained within the test of the fossil echinoid. Evidence of sediment compaction is seen in the thicker marl band, where distortions of the clay fraction is highlighted by interbedded chalk. Fortuitously, two sites, which can both be precisely located from the shore, coincide with significant episodes. A line of black basalt boulders marks the position of an outfall pipe that crosses the beach, and the cliff section in line with the pipe contains a bed of chalk with an abundance of inoceramid shell fragments and plates from the calyx of the stemless crinoid Uintercrinus. This is confirmation of the Uintercrinus socialis zone. A short distance to the west, and just over 1 kilometre from South Landing, is Hartendale Gutter, an unmistakable landmark. The chalk cliff adjacent to the fall shows a section in which there is a pair of 2 to 3 centimetre marls, the Hartendale marl, and two more examples of floods of shell fragments, including Uintercrinus plates and inoceramid bivalves. As we near Danes Dyke, the chalk beds become more massive and contain two marls, the Danes Dyke lower marls. They mark the start of the Marsupites testudinarius zone. At Danes Dyke, the chalk has been tectonically and periglacially deformed, and another Paleo Valley is cut into the disturbed chalk down to below beach level. This natural feature was utilised during the Bronze Age to construct an entrenchment in defence of the 13 square kilometres of land to the east. The Quaternary deposits have been incised by a small stream to form a wooded ravine that leads up to a visitors' car park and basic facilities. There are also cliff-top paths to both South Landing and Sewerby. Back on the shore, the eastern side of Danes Dyke shows chalk gravels, similar to the ones seen at South Landing, underlying Skipsey Till, but the more important section is on the western side. Above the weathered chalk, marked A on the annotated section, there is a chalk gravel, labelled B, with a matrix of wind-blown silt, the result of gelifluction on the sides of the valley under periglacial conditions. Unit C is of glacial lacustrine silts and sands, and like the similar deposits at South Landing, formed when ice in Bridlington Bay was blocking the outflow of streams from the north. The Skipsey Till contains a number of gravel outwash beds, an indication that ice movement is sporadic, occurring as pulses rather than in one continuous advance or retreat. Between Danes Dyke and Sewerby Steps, there are 1.5 kilometres of chalk cliffs containing the highest beds of the chalk group on Flamborough Head, most of which belong to the Campanian stage of the Upper Cretaceous. In the first part of the cliffs, however, we are reminded that we are still in the testudinarius zone by finds of the plates of Marsupites. Echinoids such as Echinocoris are also quite common, though they're often crushed, and stylolites are widespread. We saw a fallen block of calcrete at Speeton in part 1 of this series, and they're common along the southern side of Flamborough Head. As we saw at South Landing, they originate from the gravel beds between the chalk and the Skipsey Till, and a group of 4 large blocks perched on the wave-cut platform marks the first appearance of common large inoceramid bivalves. In 2019, the locality was also marked by a landslip, but this will undoubtedly no longer be in evidence. These inoceramids are Sphenoceramus lingua, the zone fossil for the beds that continue past Sewerby steps until the chalk disappears beneath the Pleistocene deposits of Holderness. From this point, the chalk becomes an alternation of thinly bedded and more massive chalk units with numerous marl partings, and several thick marl bands that can be used for at least local correlation. One such band is the 9 centimetre thick Daneswood lower marl, which is about 6 metres above the base of the lingua zone. And soon we begin to notice in both the cliff sections, but perhaps more easily in the exposed reefs of the wave-cut platform, sponge impressions and 3-dimensional sponge fossils. A 10-metre section of the lingua zone, from about 30 metres to 40 metres above its base, has been named the Flambre Sponge Bed. It occurs at the start of a change to dominantly more massive chalk units that persist to Sewerby, and contains one major marl seam, the Longwood Marl. Its most striking characteristic, however, is the quality of preservation and rich occurrence of fossil sponges, of which this is just a small selection. The top beds of the Flambre Sponge Bed crop out in the raised reefs of the wave-cut platform called Sewerby Rocks, and in the cliffs just before we reach the point where Sewerby steps come into view. A short distance east of Sewerby steps, there's a small fault, with a downthrow to the west highlighted by the displacement of the thin-bedded units just below the arrows. Immediately before the steps, the cliff provides a section that includes the Sewerby Hall Marl, a 4 centimetre thick seam that is used to correlate with inland sites. Continuing past Sewerby steps towards our final locality at Sewerby Buried Cliff, we follow the chalk cliffs to a set of pyramid-shaped outliers of Skipsey Till, noting a very prominent thick marl seam. Below the most westerly of these pyramids, the lower part of the cliff up to the prominent marl seam, the Sewerby Steps Marl, is a convenient place to log the section. Together with the 4 metres or so of chalk above the Sewerby Steps Marl, these are the highest beds of the chalk group seen on the Yorkshire coast. An aerial photograph helps to pinpoint where Flamborough Head ends and the plain of Holderness begins. A line drawn along the edge of the wave-cut platform is a good indicator of the probable intersection of chalk cliff and coastline. From this point, the pre-glacial chalk cliff stretched westwards and around the northern fringes of Bridlington towards Driffield, and from there turned southwards to Hessel. Today, the Sewerby Buried Cliff is not always well exposed because of the mass movement of overlying material, but it's possible to identify gravels overlying Devensian Skipsey Till and the base of the till on Flambre chalk. The pre-Devensian cliff marks the start of the plain of Holderness. The chalk disappears and gives way to chalk flint rubble of early Devensian age. A closer inspection of the foot of the ancient cliff shows an Ipswichian deposit of blown sand on top of unsorted chalk rubble, and at the base a beach deposit of well-rounded chalk cobbles and pebbles. This very important section can be interpreted as part of an eroding 120,000-year-old coastline with a pebble beach and regular rock falls, features similar to those found on Flamborough Head today. It was later masked by sand blown from the south, perhaps during an arid period. Periglacial conditions beginning about 30 to 50,000 years ago brought soliflucted and geliflucted slope deposits of chalk and flint rubble, and were the precursor of the Devensian ice sheet and its till deposits. Ablation of the ice sheet brought a return of periglacial conditions and outwash deposits from south-flowing streams. Our virtual trip around Flamborough Head ends here. In the 4 parts of the series, we've worked our way through about 20 to 25 million years of Cretaceous stratigraphy, from the Lower Cretaceous Hunstanton Formation, through the different formations of the chalk group, to the Campanian stage of the Upper Cretaceous. Following a considerable time gap, our next information is supplied by the Quaternary deposits that mantle the chalk and occupy the sides and bottoms of the Paleo-valleys that are cut into Flamborough Head or are banked up against the ancient cliff at Sewerby. Flamborough Head is an amazing part of the world. There is so much to explore and enjoy. As with all coastlines, change is continuous and fresh exposures can be found on every visit. I hope that this series of virtual field trips will encourage you to see it for yourself, but please remember that safety is a priority, whether you are with a group or you're alone. So make sure that you know the state of the tides, the location of access and egress points, and that you're equipped with appropriate clothing and footwear. The whole of the coastline from Speeton round to Sewerby is a conservation area, and the short stretch of coast between Danesdyke and Sewerby Steps is designated as a no-take zone. So please make yourself aware of the implications of this if you are considering collecting. Thank you for watching.